Hello everyone. Our very first example is going to be an example where we do energy or use energy against the force of gravity. So we're going to be talking about potential energy. Remember, in the notes it speaks about any time you have an object above the surface of the earth, it'll have some energy with respect to the earth. So in this question it says determine the height of a 15 kilogram hammer. So we've got a mass here, 15.0 kilograms. We're looking for height in order to do 320 joules of work. Whenever you see joules, that is going to be an indicator of work or energy. They're the same thing. Remember, and students get quite confused about this, but work just means energy is being changed from one form to another. So how much work you do on an object is the same thing as saying how much did you change this type of energy into this type of energy. Total energy is always conserved, which is what those two little flash animations were supposed to try to illustrate. You'll see that the total energy was the same in both those diagrams. You're changing energy from one form to another, work's being done, but the total energy remains the same. So since we're dealing with doing work against the force of gravity, we use the acceleration due to gravity, 9.81 newtons per kilogram. Use the potential energy formula, EP equals mgh, and we're solving for h. Divide out mg, so your height is equal to the potential energy divided by mass times gravity. Substitute the numbers in. 320 joules divided by 15.0 kilograms times 9.81 newtons per kilogram. And if you punch that in on your calculator, do that quickly here to verify the answer is okay. Make sure you bracket the denominator, because there are two numbers being multiplied in the denominator, and you should get to 3 significant digits, 2.17 meters. That means if the hammer is 2.17 meters above the stake, it'll have 320 joules of potential energy. When you drop it, it'll change that into kinetic energy. When it hits the stake, it'll change it back into another form of energy that'll drive the stake into the ground. That's what this example is really talking about.